You know, we all walk around with this hidden set of rules about how the world is supposed to work. It's like a philosophical scaffolding that we build our entire lives on, but we rarely, if ever, actually stop and look at it. And these are our deepest, most fundamental assumptions about what reality even is.
Okay, so let's get into this. These assumptions, this is what philosophers call our personal metaphysics. They define literally everything for us: what space is, how time flows, what it means for something to exist at all. We just take it for granted that, we all share one universal clock, that objects have definite properties even when we're not looking at them, and that a fact for me is, of course, a fact for you.
And for pretty much all of human history, these core beliefs were stuck firmly in the world of philosophy. I mean, sure, they were deep, important questions, but they were seen as fundamentally untestable, way beyond the reach of science and its experiments.
But what if that's completely wrong? What if we could actually put reality itself on trial? Well, that's the core idea behind this absolutely thrilling and kind of rebellious field called experimental metaphysics, where the tools of the science lab are aimed right at the deepest questions of philosophy.
Now, the whole reason this is even possible is because our everyday intuitions, that hidden scaffolding, it starts to completely fall apart when we look at the universe at its most extreme. You look at the tiny scales of quantum mechanics or the cosmic scales of relativity, and the world just stops behaving the way our common sense says it should, and that's where science and philosophy are forced to merge.
Right, so we typically imagine this really clear line between the two, don't we? Science is all about messy, practical work with testable ideas and real data. And philosophy, that's for the armchair theorists just pondering deep, unprovable truths. It's a very neat and tidy division. But as it turns out, that tidy division is a total illusion. I mean, Albert Einstein himself pointed this out. He said you can't really test the law of physics without assuming some kind of philosophy about the shape of space. And you can't test the shape of space without assuming certain laws of physics are true.
So the crucial point is this: they are completely inseparable. They're tied together in what people have called a Gordian knot. And if you can't test one without the other, that means something incredible. By testing science, you are, whether you realize it or not, also testing philosophy. Suddenly, metaphysics becomes testable.
So where did this wild idea first get put to the test? Well, the first major battle in this new arena was fought by a Northern Irish physicist named John Stuart Bell. He came up with this brilliant theorem that basically put our most cherished, common-sense ideas about reality on trial.
Bell's whole argument started with two ideas that feel so obviously true. First, locality. What happens right here can't instantly affect something way over there. No spooky action at a distance. And second, realism. A ball is red even when nobody's looking at it. He showed that if you take those two common-sense rules as fact, they create a mathematical speed limit. A hard cap on how connected two particles can ever be. But here's the shocker. When we actually run the experiment, quantum particles show connections that completely smash right through that limit.
This leaves us with this stark, unavoidable choice. We can't have both. We are forced to ditch one of our most fundamental intuitions. So either you accept spooky action at a distance, that events can just instantly influence each other across the universe, or you accept that reality itself is fuzzy, that properties like color or spin don't even exist until the exact moment they're measured. Nature is just making it up as it goes.
And this wasn't just a theory on a blackboard. Nope. In 1972, physicists John Clauser and Stuart Friedman actually built an experiment in a basement in Berkeley, and they tested it. And the results were crystal clear. Our common sense view of reality is just wrong. This was the first time a metaphysical assumption was definitively proven false in a lab.
The physicist and philosopher Abner Shimony summed up the profound implications perfectly with this quote from John Donne. The bell wasn't just tolling for some abstract scientific idea. It was tolling for us, for our worldview, for the comfortable, intuitive reality we all thought we lived in. As mind-bending as Bell's theorem was, believe it or not, it was only the beginning. The next generation of these experiments pushed the stakes even higher, asking a question that is so profound it sounds like it's straight out of science fiction. Do we all even share a single objective reality?
Okay, so this comes from a thought experiment called Wigner's Friend. It's actually pretty simple to set up. Just imagine your friend is inside a perfectly sealed-off lab. Inside, they measure a quantum particle, let's say an electron's spin, and they get a definite result, up or down. For your friend, the measurement is done. The outcome is a hard fact.
But here's the twist. From your perspective outside,
you can't possibly know the result. And according to quantum mechanics, the entire lab, your friend, their gear, the particle itself, is now one giant quantum system. So for you, they are all in what's called a superposition, a fuzzy, undecided state that's a mix of all possible outcomes at once. So, can something be a fact for your friend, but not a fact for you?
Building on this crazy paradox, physicist Eric Cavalcanti and his team developed an even stronger no-go theorem. And honestly, the conclusion is a gut punch. You've got three assumptions: locality, no spooky action; free choice, scientists can choose what to measure; and objective reality, a measurement result is a fact for everyone. The theorem proves you can't have all three. You have to pick two. Something fundamental has to give.
So this incredible journey into the heart of reality, it doesn't end with a neat answer. Of course not. Instead, it leads us to an even deeper, even more challenging question, one that pushes physics right into the territory of philosophy, and maybe even consciousness itself.
I absolutely love this analogy from the source material. When someone asked Michelangelo how he sculpted the statue of David, he supposedly said, "I just removed anything that was not David." And that's exactly what experimental metaphysics does. It acts like a chisel, chipping away at the versions of reality that are impossible, hoping that what's left behind is the true, beautiful shape of our universe.
But here's the final problem. To really test these ideas about friends and observers, we have to know what an observer even is. I mean, does a simple photon detector count? What about a single molecule, an amoeba? Or, as some people are now suggesting, could an AI running on a quantum computer be Wigner's friend? We can't know if objective reality is on the chopping block until we can answer this.
And so, this whole quest brings us right back to where we began, staring into this profound mystery of a reality that is just so much stranger and more subtle than our hidden assumptions could ever let us believe. The more we learn, the more we realize just how much we have left to understand. Which really just leaves us with a final thought for you. If you had to give up one of your core beliefs about how the world works, spooky action at a distance, a predetermined reality, or a single shared universe for everyone, what part of your reality would you be willing to chisel away?